Hello, we are going to review basic radicals and exponents so that we can kind of move past these basics throughout this next unit. So for the first one, we are looking to just simplify these. So if we are simplifying, we're looking for the greatest perfect square that goes into 48, and that would be 16 and 3. So 16 is our perfect square. So we can rewrite this as root 16 times root 3, and that's going to be 4 root 3 as my final answer. Same thing with the next one is we're going to look for root 45. We just have this 2 out in front. So we can rewrite 45 as 9 times 5. And that's going to give us 2 times the square root of 9 times the square root of 5, which would be 2 times 3 times root 5, which will give us 6 root 5. Okay, we just always need to simplify down as much as possible. When we are adding or subtracting, we first need to have the same radical, which we don't have the same radical here. So this left side we can simplify to be 3. We know 4 times 3. And so that would be 3 times root 4 times root 3. So root 4 is going to be 2, so that'll be 6 root 3. And then we can just bring down our minus root 3 here. Now there's an understood 1 out in front of that. So then you keep the radical the same, and you would say 6 minus 1 is 5 root 3. So we can combine those once we get a common radical so that we can add those. If we are multiplying, the rules are that we just want to multiply the outsides with outsides. So 7 and 2 are going to multiply together and make 14. And then the insides, 5 and 10, are going to make 50. And then we need to break down 50. So 50 is 25 times 2. And so we will get 14 times root 25 times root 2. So 14 times 5 times root 2. That is going to give us 70 root 2 as our final answer. When we are dividing, there's some rules that we need to make sure that we follow. So if we have root 2 over root 10, we could make this into just one large fraction like so, which would allow us to reduce to be that. And then when we split it back out, the square root of 1 is just 1, and we get the square root of 5 in the denominator. However, we can't leave our answer like that. We need to rationalize this because we're not allowed radicals in the denominator. So if we multiply by root 5 on top and bottom, we're only multiplying by 1. And so we would end up with root 5 over root 25. And we can simplify the denominator to be 5. So our final answer would be root 5 over 5. So we need to rationalize every single denominator if there's a radical left over. When we have 2 terms in the bottom, so if there's radical with some other number being added to it, what we want to do is we want to multiply by the conjugate. So we change the sign on the radical, and we multiply top and bottom by that. So we distribute up top. And then in the bottom, we would say 2 times 2 is 4. 2 times root 2 is plus 2 root 2, minus 2 root 2, minus root 4. And then from there, we can't do anything in the top. But in the bottom, these 2 are going to cancel out. And we're going to get 4 minus the square root of 4, which is 4 minus 2, which is just 2. And we can't do any simplifying there, so we would leave it like that since 6, 3, and 2 don't have any common factors between all 3. If you wanted to break this up into 2 different numbers, you could to say 6 over 2, which is 3, plus 3 root 2 over 2. Either one of those is acceptable. The circled one is usually the more commonly written one just because it is a little bit easier and quicker to write. So our properties of exponents, you need to make sure that you understand these. So whether we're talking about multiplying, so there's a multiplication in between there. When you multiply, you add. When you raise a power to a power, you multiply the exponents. When you raise multiple things to a power, then you're going to distribute that exponent. Anything raised to the 0 power is 1. And then negative exponents, it is going to move from that piece of the fraction to the other. So if it's in the numerator, you're going to move to the denominator, and it become positive. If it's in the denominator, you move to the numerator. So if you need to take a second to pause the video and copy this down, I would highly suggest so. And then the last 2 are quotient of powers. So if you divide 2 exponents, if you divide like bases, you subtract the exponents. And then if you are raising a quotient to a power, you just distribute the exponents to both. So we're going to simplify a few of these. And so if we have 3x squared y to the negative 1, the quantity of that raised to the third, then we need to recognize that there is an exponent of 1 here, and we need to distribute this to all of them. So we would say 3 to the third, 2 times 3 is 6, so x to the 6, y to the negative 3. Now we do need to evaluate any numerical bases, so that's going to be 27, x to the 6th, and then negative exponent means that y to the negative third is going to go into the bottom, and that would be our simplified answer since there are no common factors in top or bottom. On the example to the right, we're going to multiply, when we multiply like bases, we're going to add the exponent, so this would be really x to the 5 plus negative 2 plus 3. And so when we add that, we're going to get x to the 6. So just whenever you add like bases, multiply like bases, you're going to add the exponents. Lastly, if we have a few pieces like this, we could do one of two ways. We could simplify first, which is what I'm going to do inside the parentheses, or we could distribute the exponent first and then simplify from there. So if we simplify inside, that 3 is not going to go anywhere because it doesn't have anything to simplify. X over x to the 4th is going to remain x to the 3rd in the bottom. Y over y squared is going to remain y in the bottom. And then we have to the negative 3. So when we distribute that exponent, we just need to remember that there's a 1 there and a 1 there. So this goes to all 3 exponents. So we're going to end up with 3 to the negative 3rd over x to the 3 times negative 3 is negative 9, y to the negative 3. All the exponents are negative, so they're going to move. So we have x to the 9th up top, y to the 3rd over 3 to the 3rd, which we should know is 27. And that would be our final answer. So when they do move from one exponent to the other, from one piece of the fraction to the other, they do change value to become positive. So I hope this helps you in reviewing radicals and some basic exponent properties.